Alright, for 10.2 day 2 homework help, I have 3 problems I'm going to take a look at. The first problem I'm going to take a look at is like problem 51 from your homework. It's going to ask you to change the equation of, and this is of course an equation of a parabola, so that it represents the lower half of the parabola. And then the 2 problems that are going to probably give you the most trouble, or tend to give people the most trouble, is the tangent line problems. So we're going to find the equation of a tangent line of this parabola at that point. And then I'm going to do another one just like that. We're going to find the equation of a tangent line of this parabola at that point. Alright, so the very first one, like I said, it makes it confusing what they're asking for, but it's simple enough what they want. So when you look at this, because it's y that's being squared, this parabola is opening to the right, because this is a positive 2. So positive 4, negative 1, if I really wanted to graph it, it looks something like this. And what they're asking you to do is to change the equation so that it represents the lower half of the parabola. They want to know what this is. Well, think of what the top half of that parabola is. That's just a square root function. That means the bottom half is also a square root function. In other words, what are they trying to tell you to do? They're basically saying take that equation and solve it for y. So if you were to square root both sides to get rid of the square, you would have y plus 1 is equal to the square root of the quantity 2 times x minus 4. And then you could go ahead and subtract 1. And remember, when you take the square root of something, you're supposed to have a plus or minus in front. Well, this is the plus part of it. This is the minus part of it. So when you subtract the 1, your final answer would be y is equal to negative, because you want the lower half, of the square root of, and you could distribute it if you wanted to, or you could just leave it as 2 times the quantity x minus 4 and then minus 1. That is the equation of the lower half. If you change that to plus, that would be the upper half. So that's what number 51 is looking for. Alright, looking at the tangent line problems. First thing you want to do when they ask you to find the tangent line is remember the 4 steps that you have to run through, and then before you even get carried away doing those, make sure that this equation is in standard form. And it is. I don't see parentheses, but that's fine because I could technically say it's x minus 0 and then y minus 0. The square term doesn't have a number in front. That's good. So everything looks the way it's supposed to. I'm going to draw a quick graph so that when I graph it, I can kind of talk about the processes in terms of what it is that we're looking at. You wouldn't have to necessarily do this, but I recommend doing it. It's a graph. It's x squared, so it's either up or down. That's a positive 2. So my parabola is opening up. And you don't have to be all that accurate. The point that they gave you is on this parabola. It's negative 3, 9/2, so it's probably somewhere right about there. And of course, definition of a tangent line means it's going to touch it just once, like this. So there is the equation, or this is the tangent line that I'm looking for. Now, the axis of symmetry, which is right here, will always intersect that tangent line at a specific point, and that point is something that we are actually trying to find. So I'm actually trying to figure out what this is. Why would I want to know what that is? Well, think about it. If I have that point, they gave me that point, I would have 2 points on the tangent line. I could just run through and do my y equals mx plus b stuff. And that's what the goal is. I need to figure out that point. So now I know what I'm trying to do. Now how do I do it? Well, first things first, you want to start by finding the focus. So looking at my equation, I can see that 4p is actually equal to 2 here. So p, if I divide both sides by 4, is 2/4 or 1/2. So the first step that you have to do is figure out what the focus is. Well, I can see the vertex points at 0, 0, and I got that from the equation. The focus, since it's opening up, is right here somewhere. It means I have to go up 1/2. So my focus is going to be the point 0, 1/2, going up 1/2 unit from the vertex. So there's step number 1. I found the focus. Now, why would I want to find that? Well, I need the focus because what I'm looking for next is the distance between the focus, which I just found, and the point of tangency, or that point that they gave me. So, step 2, find the distance between these two. So I get to use my distance formula, and it's 0 minus the negative 3 or plus 3. And again, the order that you're doing this isn't going to matter because you're squaring it. Plus, and then I have 1/2 minus 9/2, or the other way around, squared. which is going to give me the square root of, that's going to give me 9. That looks like it's negative 8 over 2, so negative 4 squared, or 16. That distance is actually 5 units. And so now if you remember that reflexive property that we talked about in class, why would that be important? Found the focus, got this distance to be 5. Why is that important? That reflexive property, even though it's not going to look like it on my picture, says that whatever this distance is exactly the same. So if that distance is 5, I know this distance is 5. And since I know the focus is 0, 1/2, this point is just 5 units below it. And I know it's below it because the parabola opens up. If the parabola had opened to the right, it would be 5 units to the left of it. That's why I like drawing the picture. It gives me something to look at. So it's 5 units below it. Below means I should do it to the y value, so just take this y value and subtract 5 from it. That'll give you what I call the second point, since they don't have a fancy name for it. So if I subtract 5 from that, or 10/2, that second point is 0, negative 9/2. That's the third step. So step 1, figure out what the focus was. Step 2, find the distance between the focus and that point of tangency. Step 3, use that distance to figure out what this second point is. And remember, that was what the goal was. Once I had those 2 points, once I found this one, once I've got those two, it should be easy to find the equation of the line. It's just y equals mx plus b, something you did back in Algebra 1. So I've got y equals, let's go ahead and find the slope first. Slope is going to equal 9/2 minus a negative 9/2, or 18/2, or 9, divided by negative 3 minus 0. And ask yourself if that makes sense. I have a slope of negative 3. Look at that line. That looks like it should definitely be a negative slope, so yep, that makes sense. If that was positive 3, you know you probably got something mixed up. So my equation is y is equal to negative 3x plus b. You would want to pick a point and plug in. You can pick either one of these. Now we get lucky. The axis of symmetry is running right through, or right on, the y-axis, which means that actually is the y-intercept. So I really don't have any work to show. Otherwise, plug in a point and solve for b. But your equation would be y is equal to negative 3x minus 9/2. And that's the answer that I will be looking for and that I would take. If you go in the back of the book to look at the answer, this isn't what they're going to give. They're going to give the answer in, well, they're going to set the equation equal to 0. And they're going to get rid of the fraction. So multiply everything by 2. Or imagine if I multiplied everything by 2, I would have this. And then imagine if I moved everything to the left, I would end up with 6x plus 2y plus 9 equals 0. That's the equation that you would see in the back of the book, but this is the same thing. And that's all I need. If you wanted to give me that, that's fine. So 4 steps that you have to go through. Find the focus, find the distance between the focus and that point of tangency, use that distance to find the quote-unquote second point, and then use the point of tangency and that second point to find the equation of the line. Alright, so same process. Want to start by graphing it. Again, I'm going to look at this and say, is it in standard form? And that's actually the easiest mistake to make on this. You don't really see a whole lot going on, so you assume it's in standard form, but remember, the squared term should not have a number in front of it. So I'm going to just kind of rearrange the order here. I'm going to divide both sides by negative 2 because I don't want the x squared to have a number in front of it. This is the equation in standard form. If you go ahead and you look at 4p and you say, oh yeah, p is going to equal whatever using this, you're going to be wrong. It's this that you have to use. So that, for this problem, is probably the easiest mistake to make. Okay, so let's go ahead and draw myself a picture again just so I have something to look at. It's a parabola opening up or down, negative, so I know this one's opening down. The point that they gave us was 2, negative 8, so again, kind of ballparking it, let's just say that that's 2, negative 8. This is the tangent line that I'm looking for. And here's my axis of symmetry. Again, it happens to be running through the y-axis, which is going to make the y-intercept a lot easier to find. Here's the quote-unquote second point that I'm trying to figure out. So step 1, need to figure out what the focus is. I know the vertex point is 0, 0. I can now take this and set it equal to 4p and try to solve. So if I divide both sides by 4, I end up with negative 1/8. I am going down here to get the focus, so my focus is going to be 0, and then subtracting 1/8 from 0 gives me negative 1/8. There is step 1. I've got the focus. Step 2, Need to figure out what the distance is between this focus and this point of tangency that they gave me, which was 2, -8. So the distance is equal to the square root of x value minus x value, so 2 minus 0 squared, plus y value minus y value, or -8 minus a negative, so plus 1/8 squared. Alright, and it looks like I'm going to end up with 4 if I square this one, plus, probably going to want to get a common denominator. This is -64/8 plus 1, so this is going to be -63/8 squared. And I wouldn't give you numbers like that on probably the test, not that you can't multiply 63 times 63. I know the denominator is 64, but we use a calculator to help ourselves out here a little bit. So I've got -63 divided by 8, and I'm going to square that. Remember, if you want to get that number as a fraction, you just have to go to math and then hit enter twice, and it'll convert that to a fraction. So there is what this is. I'm adding 4 to it. Now, I'd prefer that you show your work when you're doing this, because most likely you wouldn't have a calculator on the test, but on the homework it's fine, you can use this. I know that 64 times 4, if you're not sure what it is, quick throw it in there. You should be able to multiply that by hand though, if you need to. There's what 4 is if I change it to a fraction. And now of course you're going to add the numerators together, and again, it wouldn't take you long to add those together, but you're going to get 4,225 over 64. Now, you shouldn't be getting numbers like this on the test if you have a problem like this, but just saying, if you do run into it, you should be able to do it by hand. Now, like we mentioned in class, it doesn't mean that this has to happen, but for any problem that we do, this is kind of a way to check yourself. This number cannot have a radical in it. If it does, when you're all done simplifying, you did something wrong. Either you simplified this wrong, or you've got the wrong focus. So that means when I take the square root of 4,225, it should be an integer. If it's not, I know I did something wrong. So I'm going to take it to the 0.5 power, the square root of it, and it's actually 65. I know the square root of the denominator is 8. There's the distance. So that's one way to check yourself. Like I said, it's not a guarantee that that has to happen all the time, but for any problem that we do in our homework or test or quiz or wherever you see this, that will happen, where this will be a nice number. If it's not, you know something's wrong. Alright, so there was step 2. Now I know the distance here is 65/8, which means this distance is also 65/8. So from the focus, go up 65/8, and since you're going up, you're adding it to the y value. So step 3, come up with that second point, like I called it. And since I'm going up, the x value won't change. If I add 65, that's going to give me 64/8, or 8. And now my last step, I've got this point on the tangent line, this point on the tangent line. Go ahead and find your slope, and then write your y equals mx plus b equation. So it's 8 minus a -8, or 16, divided by 0 minus 2. Ask yourself if that makes sense. Looks like it's a negative slope, so yeah, it probably should be -8. And then because the axis of symmetry is on the y-axis, the second point that you come up with will actually be the y-intercept. If it's not, like I said, no big deal, or if you're not sure, plug in that for, so do this, y equals -8x plus b, plug in 0, 8, or 2, -8, and you'll get the same thing. But your answer will eventually be y equals -8x plus 8. Again, the back of the book is going to move these two over to the left-hand side, but you don't have to do that. So it's a nice couple problems to take a look at, finding that equation of the tangent line. When you get to calculus, and if you've got friends that are in calculus, they're probably trying to show you easier ways to do it, and there definitely are easier ways to do it. But for right now, you need to learn this process. We'll actually learn the easier way next chapter. All right, that is homework help for section 12.2, day 2. If you have questions, feel free to come in and ask for help.